In this video, we will look at question number 9 of practice exam 2. We want to compute the directional derivative in a certain direction, and we also want to know when this function will have a maximum rate of change. What is the direction that we have to travel in order to get the maximum directional derivative? Okay, so first let's do the directional derivative in this direction. And in order to do that, first we're going to find the gradient. So this is where we're taking the derivative of tangent of something. So let's take a look. Derivative of tangent of something, we need to know that that is secant squared. And then we multiply that by the something prime. Okay, so this is just called chain rule, regular chain rule. So tangent of something is secant squared of the same something. So it's going to be secant squared of the same exact argument. Nothing changes here. And then we multiply by the derivative of the argument with respect to x. Note that the argument consists of three parts that are added and subtracted. Or no, not subtracted, just added. So x with respect to x will give us 1 plus 6y with respect to x, because it's a number, will give us 0. And for z with respect to x is also a number, so that'll also give us 0. So that's partial derivative with respect to x. Similarly, if I want partial derivative with respect to y, this will be the same secant squared of the same something, but this time I take the derivative with respect to y. And so x will drop out, 6y is 6, 4z will drop out, becomes 0. Okay, and then finally, let's take a look at the derivative with respect to z, which is going to be similar, secant squared of the same something multiplied by the derivative of the something with respect to z. So x has no z and it's added, 6y has no z and it's added, and 4z is 4. So that's my gradient. Okay, so that I will have to type here, which will be kind of long. And that's just times 1. So let me see if I can just copy paste that here so I don't have to type it again. Okay, so this looks like that's a 6. And the last one is the same secant, but that's a 4. Okay, so once we find it, we want to plug in the actual point. So we are going to plug in negative 10, 1, 1. Okay, so let's see what happens. So let's me actually compute what is x plus 6y plus 4z. So x is negative 10 plus 6 times 1 plus 4 times 1, but that's 0. So you should know that secant is 1 over cosine, and cosine of 0 is 1, and secant of 0 is also 1. So if you're not sure, you will have to figure out what is the cosine of 0. You can plug that in your calculator. Make sure the calculator is in radians. So cosine is 1, and then secant is 1 over cosine, because I am pretty sure that the calculator doesn't have secant. It just says sine, cosine, tangent. So that's all you have. Okay, so but secant squared is 1, so that is then makes it very easy. So this will just be 1, 6, and 4. Okay. All right, so that's the gradient. It's 1, 6, and 4. Now they want the directional derivative. So in order for us to compute that, we have to look at which direction they're talking about. So the direction vector here is 3, negative 2, negative 4. And we need to compute the dot product of the direction vector and the gradient vector right here. And this is the direction. However, the direction should always be unit length. So you need to normalize vector v. In other words, divide by its norm. All the components are going to be divided by its norm or magnitude. So what is magnitude of vector v? So remember that the magnitude is computed as taking the squares of each component. If you are inserting a negative, make sure it is in parentheses. Otherwise, I would recommend you drop it. And whatever this is will have to be divided by each component will be divided. So this will be like 9. This is 4. This is 16. So looks like that's, I think, square root of 29. So everything here will be divided by square root of 29. So for the directional derivative, we're just going to take 1 multiplied by 3 plus 6 multiplied by -2 plus 4 multiplied by -4. And this whole thing will just have to be normalized or divided by square root of 29 at the end. So let's take a look at the numerator. So we've got 3, subtract 12, subtract 16, and then we divide it by square root of 28. Okay, so let's see if we can compute what that is. And that's -25. So that will be my directional derivative. Okay, so that's correct. The next thing we need to do is figure out what is the maximum rate of change of this function at the point P. So you need to know, and I think it's also on your formula sheet, that the maximum rate of change at a specific point, so the point was -10, 1, 1, is equal to the magnitude of the gradient at that point. So the point is -2, 10, 1, 1. And what you have to be very, very careful of is that you do not involve your computations connected with vector v and magnitude of it and dividing by it and all of that. This had nothing to do with part D, because part D is just saying in which direction will it be the maximum. It has nothing to do with that specific direction, which will likely not be the maximum. What you need to concentrate on is you need to find the gradient, which you already found. You just have to identify where it's at. And again, it has nothing to do with vector v. So find the gradient, which is 164, and find its magnitude. You have not done that yet. So don't think it's square root of 29. It has nothing to do with it. So it's going to be magnitude of the gradient, okay? Not magnitude of the direction vector. So magnitude of the gradient would be 1 squared plus 6 squared plus 4 squared. So this will be 1 plus 36 plus 16. And that's going to be under the root. So here I go 1 plus 36 plus 16, that's 53. Okay, so square root of 53 will be the answer. Now, in terms of direction, the theory says that the direction of the maximum rate is the gradient, okay? However, they always want you to, I mean, not always, but most of the time on the homework, they want it as a unit vector. So you need to divide by the magnitude, and you just computed it. So all you have to do is take your gradient, which again has nothing to do with v, go back to your gradient, so 164, and normalizing by dividing by the magnitude, which was square root of 53. It wasn't square root of 29. See, people get confused here. So you take your gradient, whatever 164, and divide it by its magnitude, which was square root of 53, okay? So it's not the same thing as that vector v thing. So I'm just dividing each component by square root of 53.